It means derivative. Okay, good. Okay, the first one is called the power rule. And you guys know this. We had like the Arnold Schwarzenegger moment. The power rule says if I have x raised to a power, what do we do?
Bring the power down.
Bring the power down.
Bring down.
And decrease it by 1.
Decrease the power by 1. So the derivative of x to a power is the power times x to the power minus 1. Bring that power down, reduce the power by 1, done. Here comes another easy one. The derivative of a constant. The derivative of a constant. The derivative of a constant. Adriana? The derivative of a constant is 0. Always. Always, always, always. Now here comes the tricky one. The derivative of a constant times a function. So f of x is my function, whatever it is. C is a constant. What we talked about on Friday, because we've had a 3-day weekend and we may have forgotten some of these things, is you ignore the constant and then you just take the derivative of the function in the way that you normally would. So let's clarify this one. Here we go. The derivative of x squared. Think about it for 3 seconds before you say anything. The derivative of x squared, 3, 2, 1. Oh, so awkward. Derivative of x squared, everyone's going to tell me is?
2x.
2x, right? Maybe you said, oh, he said 2x to the 2 minus 1. That's really 2x to the first. That's just 2x, right? We got that. What about the derivative of x squared plus 6? The derivative of x squared plus a constant
2x.
is 2x plus the derivative of that constant, which is 0. So it's just 2x. Everybody's okay with these, right? This is the one that messes everybody up. The derivative of 6 times x squared. Derivative of x squared, everybody knows. 2x. The derivative of just 6. 0 because it's a constant. But when you are taking the derivative of a constant times a function, the way it works is you ignore the constant. You leave the 6 alone. And then you take the derivative of x squared, which is 2x. So your derivative is going to be 12x. Done. So there's the derivative of a constant, which is 0. And the derivative of a constant times a function works a little bit differently. We're good? What I want to do is I want to give you guys about 6 minutes to work with these 7 problems. I care greatly about the first 6. If you get to the 7th one, fabulous. I don't think that you really will, but if you do, great for you, Abraham. The person who is in control of the cups, the shortest person in the group gets control of the cups. Eunice, I was thinking about you. 6 minutes, show me what you've got. I want to see great notation. Jasmine, can you be an unofficial member of this group over here? You don't have to move if you don't want to. 6 minutes, make it happen.
I'll put the camera on you guys. Edgar.
Okay, and we're working. Jose. Jennifer.
4x to the third.
Oh, Jesus. 4x
squared plus 2x plus wait, what's something to the x1?
Plus x and 0 is 1. No, plus 1. Plus nothing. That's nothing. No, I think it's going to be 1 plus 1, right?
No, because this is a...
I know, but still, like... It's just plus 1.
Yeah, because this is something that's
0.
and then this is a 0.
Es que María nunca quieres entender.
Okay, so the most up to date grades.
And then do we leave it as that big thing?
Alright, can I get all the stuff from all the people here?
That's -1.
1, x to the power of 0.
6 times negative 1 squared. So that's like negative 12 minus 6. It's negative 18. Is that right?
I got 12t cubed minus 6t
You
squared.
gotta plug in negative 1.
All the stuff from all people?
I'm not there yet.
Okay, what happened?
I got there. What'd you get, Christian? Are you there yet?
So,
Negative 18.
Yeah, I got negative 18. F prime prime of x. Blech.
Bien hecho, ¿verdad? Bien hecho.
It's only because of the summer work.
You?
Whoa.
So 1, but then is it 1 consider constantly
this is not all the stuff from all the people.
x to the power of 0.
Prime
Oh,
prime.
sorry.
No, keep that till tomorrow. Okay. All the stuff from all the people. Don't worry about the staple. Here. All the stuff. All the stuff. All the stuff. Thank you much.
12x squared. You just do the same thing over again. Wait, so in this case, would 1 still be a constant? So then it just cancels here?
1 will still be 0.
Yeah, so it's 12x squared plus 6x plus 2.
Feel this written. Put your hand right here.
That would just become constant.
What is that?
No, it doesn't start off
No, it's not. It's something.
All right, spoilers. 1 and 2 are up on the board.
Can I
Number
zoom
1,
in?
4x cubed plus 3x squared plus 2x plus 1.
I can zoom in.
Okay, one thing I did not get a chance to check on when I was walking around. If f of x is x to the 4th, you better be labeling this correctly. This is f prime of x that's equal to 4x cubed plus all this stuff. F of t equals 3t to the 4th minus 2t cubed plus pi. F prime of t is 12t cubed minus 6t squared.
I'm trying.
What happened to the pi?
There.
Christian, what happened to the pi?
It turns into a 0
It turns into 0. Why?
because pi is a constant.
Pi is a constant, and what do you know about the derivative of a constant?
0.
The derivative of a constant is, so it's not that pi became 0 when we took the derivative of pi is 0. And then to find f prime of negative 1, just plug in negative 1 everywhere there was a t, and we should get negative 18. Just a quick show of hands, how many of you guys got both of those perfectly right? Nice. The derivative powers are strong. Keep going.
You guys get it.
Keep going. Yep. Yes. Why is it a constant?
For G and T,
No, that's not why it's a constant.
that.
Constant means never changes.
What is this?
Okay? So why is pi a constant? It's always 3.1 forwards and stuff, right?
I got
That's what I mean by
x
constant.
squared.
Just like I am going to constantly do high expectations. Just like over here, I like this idea. What I don't love about this is I don't know what it's actually.
G and T,
I haven't labeled these.
that.
Labeled.
Can you not? Like, just I'm not allowed to play it.
4, 8, 12.
Christian, for number 3. Obviously, like, how do you do it though?
Don't talk to me like that. What's wrong with you?
He was like, I was like, what do you do? He said, that. What you had for this one?
I got 12x squared plus 6x plus 2. Yeah, because the x becomes a 1 in 2x. Unless Mariah is wrong.
Just plug in 0 for t.
What?
don't include a 0 or t.
No, but like I don't get this. What is this? Like I don't. This is like.
Once you get to the part 4x cubed plus 3x squared plus 2x plus 1,
Square plus 6x.
then you multiply 3 times 4 because the 3 comes down, right?
Alright, more spoilers.
And then 6x because
Number 3, and number 3 I'm asking for F prime prime.
when x is by itself, or the 2 for
F prime prime, but really we're gonna call this,
and then, so then we
it
get
means the derivative of the derivative. We're not actually gonna call it F prime prime, Kimberly. Please don't go to college and say, my calculus teacher called it F prime prime. Never mind. F prime prime. It's F double prime. How do we get F double prime, David? You take the derivative of the derivative. So in number 1, you already found the derivative, and now we just find the derivative again, 12x squared plus 6x plus 2. Everybody good? Okay, now number 4. I want to do number 4 and number 5 with you guys relatively quickly. Okay, number 4, g of t equals 5t to the 9th minus 3t to the e plus e squared. Find d dt of g of t at t equals 0. What am I really asking for? Find the derivative at not x equals t. So first find g prime. I bet we can do this really quick. Derivative of 5t to the 9th.
45t to the 8th.
Okay, maybe you went straight to 45t to the 8th, or maybe you said it's 5 times the derivative of t to the 9th, which is 9t to the 8th, minus the derivative of 3t to the e. 3 times take the derivative of t to the e. Oh, we're not so confident now.
3et.
Is this your variable raised to a power?
Yes.
Then use the power rule.
3et.
The power rule says, bring that e down,
Bring daddy.
times t to the e minus 1.
You're not funny.
If it was t to the 4th, no one would even stop to think to tell me 4t cubed. You would bring the 4 down and you'd reduce the power by 1. Bring the e down, reduce the power by 1. Plus, think about this for 3 seconds before you say what the derivative of e squared is. 3, 2, 1. What is it?
2e.
2e. Jose, what are your thoughts on this? One more time?
It's a constant.
It's a constant.
Oh, e.
How do you know this is a constant?
E stands for another number. Like
E stands for some other number. Thank you for leaving the mystery in there. It's 2.718 and some stuff. So e squared is still a constant. And so the derivative of a constant is 0.
Settle.
Now to find g prime of 0, just plug in 0. So I've got 5 times 9 times 0 to the 8th. Minus 3 times e times 0 to the e minus 1 plus 0. That's a whole lot of 0.
Just leave it? Or no?
Well, 5 times 9 times 0 to the 8th is 0. There's a whole lot of
What
zeros.
did I-
Okay, the last one I want us to talk about, number 5, because it's going to make your life better later. H of x equals 1 over x plus the square root of x. Does anybody see this as the power rule? No, Amy, you see some power rule stuff that you can do? What do you see?
The square root of x can be x.
Square root of x is the same thing as x to the half power? Is everybody okay?
Yes.
Okay, that's not the derivative, that's just rewriting it so I can use the power rule. Rumbeer, what do you see?
1 over x can be rewritten as x over negative 1.
Careful, I heard x.
Not over negative 1. X over negative 1.
Good, you meant x to the negative 1 power.
Yeah.
So this is h. That's not the derivative, this is just rewriting it so I can use my power rule.
See.
Okay, take 30 seconds, find the derivative. Don't look up, I'm going to find it as well. Stuff. Label that. That's h prime. Let's see h prime. You don't have to simplify. I know, once you figure something out, you're not going to let it go. All right, so if all goes well, you use your power rule. You bring the -1 down, reduce the power by 1, it's -2. Bring the power down, it's a half. Reduce the power by 1. You could leave your answer as -1 times x to the -2 plus 1/2 x to the -1/2. Love it. Or you could say h prime is -1 over x squared plus 1 over 2 square roots of x. How many guys came up with one of those versions as your derivative? Life is good. Your derivative life is so much better than it was in Unit 1. God, it was horrible in Unit 1. Remember back in those days? Groan if you remember back in those days. But now we're in Unit 2. It's good stuff. Sorry if I spit on Noemi and Edgar and Christian. Okay? We're in Unit 2. Good stuff is happening. We're going to study the function. We're going to look at the derivative. We're going to look at the derivative of the derivative. We're going to look at the derivative of the derivative of the derivative. We're going to look at an antiderivative. Life is good. Oh my God, all the notation that's coming your way. All the vocabulary that's coming your way. Oh, good stuff. Love it. Everybody okay? You guys look like you've never been more miserable in your lives.
It's Tuesday. Could have been Monday.
It's fake Monday again. All right, so I've got some new vocabulary terms for you. I've got some power teaching stuff for you. Oh my God, we're going to do a lot of writing today. Love it. I have one new vocabulary word, just one. And this new vocab word is the word differentiable. What's the word?
Differentiable.
Differentiable. What does it mean for a function to be differentiable at a point, Nora? You just underlined it? Okay, a function is differentiable if the derivative exists. That's all. That's it. Differentiable means derivative exists. Okay? So who can tell me how you can find the derivative at a point? Oh, it's fake Monday. Yes. How? Let me ask that question again. Who can tell me how you find the derivative at a point? One person? 2, 3, maybe 4? Kimberly, how do you find the derivative at a point?
Set the limit as x approaches a.
Okay, so limit as x approaches a.
And then f of x minus f of a
F of x minus f of a.
divided by x minus a.
F of x minus f of a divided by x minus a. This is how we find the derivative, okay? Okay, one notation for this is f prime of a. Another notation? Tan. If I ask you to find the derivative at a point, this is a way that you can go about doing it. And if that derivative exists, then we're going to say it's different. The function is differentiable. That's all that it means. So tonight when you go home and you're having dinner, you're like, hey, Mom, Dad, I learned a new word today. The word is differentiable. It means that the derivative exists. That's all. Done.
What derivative?
And then they might say, what?
Okay.
All that we care about is this. A function is differentiable means the derivative exists. So the just right question that I hope someone out there would be thinking about, maybe that's the deep thought Rambir's having. It's a really deep thought Rambir's having there. It was a really deep thought. Yeah. Maybe the really deep thought you're having is, does the derivative always exist? I'm sure someone was thinking this question, right? Does the derivative always exist? No. If the derivative always existed, then everything is differentiable. So, here's the key. Here's the key. When I say the derivative exists, that means you can find the derivative, right? And the derivative involves limits. Anybody remember why a limit wouldn't exist? Why wouldn't a limit exist? Edgar, why wouldn't a limit exist? Edgar, why would a limit not exist? Oh, Edgar, you looked so eager. I thought it was there on the tip of your tongue. If they don't equal, Eunice, can you help him out? If the limit from the left and the limit from the right are not equal to each other, then you would say the limit doesn't exist. No, you didn't actually say those words. I will play back the game footage if we need to. If a function is differentiable, the derivative exists. But a reason why the derivative might not exist is that a derivative involves limits. And Martyr, do limits always exist?
Okay, no.
No. Right? Sometimes you have a limit from the left that's one thing and a limit from the right that's another thing, and that is a problem for us. We're okay? There are other reasons. So I want you guys up on your feet, please. And Mariah, maybe you want to move the camera.
Okay.
Okay. You guys definitely had the look of teenagers that needed to get up on their feet.
Ah!
Okay. I'm gonna go through the motions once, and Mariah's gonna film you guys. Oh, I love it. Ugly people, stay in the back, please. Okay.
Stay back.
Edgar,
It's her
stay with me.
birthday,
You
by
are
the way.
wasting way too much of my time right now.
That's
In order
Edgar.
for a function to be differentiable at a point, sometimes people just use the word smooth. Instead of saying differentiable, they say smooth. Like I am smooth. Like some of you are smooth. Okay, you are smooth. In order for a function to be differentiable at a point, that is smooth. Stretch those. So you're smooth. The function must be, watch for it, continuous. Why am I doing that? At a point. Function has to be defined.
Because clubbing never
Limits have to exist.
You have to equal each other.
And whatever the function is defined to be, the limits have to be the same, right? So in order for a function to be differentiable at a point that is smooth, the function must be continuous. There can be no cusp points.
No.
Cusp points. There is a parent function that you know of that has a cusp point. No one's ever called it a cusp point. What function is this?
Value.
The absolute value graph. It has a sharp point, like so sharp it could poke you in the eye. Okay, that is a cusp point. If you have a cusp point, the derivative doesn't exist. And there can be no vertical tangent lines. Now careful. I said vertical tangent lines, and I saw some of you, you're like, oh yeah. No, not this. This is
Vertical asymptote.
vertical asymptote. I want you to show me like a tangent line. If your tangent line was looking like this, you would tell me what's happening with your function. Your function's increasing. If your tangent line looks like this, your function is decreasing. If your tangent line looks like this,
Stay constant.
and it's constant, if you got a horizontal tangent line. If your tangent line is vertical, going perfectly straight up and down, your function is not differentiable there. Are we okay? Okay, so let's take it from the top on the count of 3. 1, 2, 3. In order for a function to be differentiable at a point that is smooth, the function must be continuous. There can be no cusp point, and there can be no vertical tangent line. Good. Teach it to somebody near you.
In order for a function to be at that point, there can be no vertical tangent line.
All right. Have a seat, Edgar, before you hurt yourself. Or, even more importantly, Giselle. All right. So we're going to do this slightly out of order, and that's okay. So you're going to find, I think you're going to find differentiability when you see the graph very easy. So this is on the bottom of page 2. I know I'm skipping a little section. That's okay. Look at that graph. My question for you is, are there any places where the function will fail to be differentiable?
Yes.
Yes.
Where? Let's get some hands on this. Where? I want like 12 people. Where will this function not be differentiable? Marvin. Okay, so you're saying not differentiable at x equals -1. Now tell me why. What's the because?
Did not continue to.
Ah!
He said it.
F of
It's on your paper.
did not continuous.
Because the function is not continuous.
What's that thing before the X?
At x equals -1. So that is one place. Anybody see any other place? Any other place? No, Amy?
At x equals 2.
So not differentiable at x equals 2 because
There's a cusp point.
there is a cusp point.
Yeah, okay.
And the word is C-U-S-P. If you're not spitting when you say it, you're saying it wrong. Cusp point. Right? It doesn't have to be, hold on, it doesn't have to be two lines coming together, but it has to come together in a sharp way. What was the other word I gave you for differentiable? It could be
Criminal.
Look at your graph. Where your graph is smooth, it is differentiable. Not continuous here. Certainly not smooth here. It's pointy. Okay, so that's what we mean by not differentiable. We got this under control?
Yeah.
Okay, so if we know where the function is not differentiable, where is it differentiable? Where is it differentiable? Mariah, where is it differentiable?
When x equals 0.
At x equals 0, that is a place where the function is differentiable. I agree. The function is smooth, it is continuous, no cusp points. I think you can go even bigger than that. Eunice, where do you see the function is differentiable? At x equals 1? So I heard at x equals 0, we're differentiable. At x equals 1, we're differentiable. I think you can tell me even more. Rambir, what else can you tell me?
Is it if you make it into piecewise function?
Okay, so tell me more about that.
So, bro, I'm assuming this goes into negative infinity.
Okay, don't make that assumption.
Alright, so
That's a dangerous assumption. I don't see any
JK.
arrowhead, so let's assume it ends here, and let's call that x equals -4.
Alright, from -4 to -1.
Is everybody okay? From -4 all the way until x equals -1,
Yes.
is the function continuous?
Yes.
Yeah.
Do we see any sharp points?
No.
Do we see any vertical tangent lines?
No.
No. So you are differentiable from -4 to -1, and I'm going to use brackets at the -4. How about -1?
No.
Gonna have to use parentheses. Okay, Rambir, you're frozen for a little bit. Where else? Where else are we differentiable? Where else? Where else? Where else? Where else? Edgar, where else?
From -1 to 2.
From -1 to 2, I agree. Martia, where else?
From 2 to 4.
From 2 to 4, and at 4. And I realize we're kind of making an assumption that this is x equals 4. The graph is not labeled as clearly as I would like to. It is easier to look at the graph and say, where am I not differentiable? And then say, oh, I've got that, so it's differentiable everywhere else. With the graph in front of you, this stuff is easy. Everybody okay? All right, so there's partner practice on the next page. There's 3 functions. I want you to tell me in all 3 cases where the function is not differentiable and why the function is not differentiable. I want to see the words. Right, the leg's not working.
No, I think I need to like sit back more, but I feel like if I sit back more, then I'm just gonna be like in the middle of the room.
Okay, so
It's kind of weird.
to lock it, you just turn it to the left, and then they lock, and you should hear a little pop. And so these aren't going up or down. Okay, and I definitely don't want this to be the thing that like you're worried about. Oh, but now you can't see it.
Yeah. Cause I think it would, like, I
I think
don't
you
know.
guys are gonna have to switch.
Yeah, I think that's what I
Are you okay?
was gonna say.
Yeah, let's switch because you need to be on the side that you can see what's happening. Sorry. Oh, 4. Okay.
You can look at you.
All right. It's been a while since the name selector app.
Okay.
All right, Nora.
X is
First graph. Tell me where this function is not differentiable.
from negative. Oh,
Hold on. Not differentiable.
Yeah.
Not differentiable where?
When x equals a.
Okay, when x equals a, or I'm going to say at x equals a, and Jasmine, why is it not differentiable there? The function is not differentiable at x equals a because?
It's not oscillation.
Because there is a cusp point. All right, graph number 2. Coming to Edgar. Not differentiable where?
Add x equals -4 and 0.
Okay, at x equals -4 and at x equals 0. Is everybody okay? All right. Daisy, why are we not differentiable at x equals -4?
Because there is a cusp at, there is a cusp point.
Because of a cusp point. Okay, and Edgar, the other one you told me was at 0.
Yes.
All right, and at x equals 0, and that goes to Anthony. Why not at x equals 0? What's happening at x equals 0? Hold on, at x equals 0, it's not a vertical tangent line? Because, right, not continuous or discontinuous. All right, good. All right, graph number 3, Rombier, not differentiable where?
At x equals 4.
At x equals 4, tell me why, Rombier.
Because of the plus point.
Because of a cusp point. Okay. Is everybody feeling like visually this is easy stuff?
Yeah.
Right, you can see it, you're like, it's not continuous? Good. Cusp point, good. Now, we talked about there's one other reason. What was the other reason? Vertical tangent line. I want you to look at these 3 graphs one more time. This is the hard part. Is there anywhere on any of these 3 graphs where you would draw a tangent line and the tangent line is vertical?
Yes.
Don't talk to me, talk to your neighbor about this. Look at the graphs. If it helps, use your pen, use your pencil to like represent a tangent line. Is my tangent line vertical here? No. Vertical here? No. Vertical here? No. There are some places where there are vertical tangent lines, but it's hard to see. Use your pencil.
I'm sorry, babe. Camera ready. It's the action.
I mean, like let your pencil or your pen be the.
We're talking about where the vertical tangent lines are.
I don't get it.
Wouldn't it be the second one? Because that's
Well,
a straight
are
line.
we looking for?
Yeah, I was thinking that's what.
Is it just because it's a straight line? Got it.
Here,
Maybe wherever.
your function's not continuous.
I don't know because we've always.
All right,
had
so-
tangent points, like, right here.
Finding the vertical tangent line is tricky. It's also hard to even show it on the graph that you have a vertical tangent line. Here's where they are. Here. There's a vertical tangent line here.
Okay.
Look at this again. Look at it with fresh eyes. Let your pen or your pencil be your tangent line. Tangent line here is decreasing, right? Negative slope. Over here, still decreasing. Over here, still it starts to get vertical somewhere around here. It's hard to know for sure that you have a vertical tangent line. Normally what's going to happen in the problem, they're going to tell you that there is a vertical tangent line, and then you know, oh, vertical tangent line means not differentiable. We're okay? It's hard to know for sure because this morning I was convinced that not only did I have a vertical tangent line here, so I'd say not differentiable, where is that? Is that -1?
Yeah.
Because of a vertical tangent line? This morning I was convinced that there was a vertical tangent line in one other place on the graphs. No, Amy, where do you see it? 2.5. Like somewhere like over here. I think it's hard to tell from the graph, is my tangent line really vertical? But I think somewhere between 2 and 3 the graph might have a vertical tangent line. Might. Hard to know for sure. Visually, easy to figure out continuity. Easy to figure out cusp point. Like cusp point, that's our jam. Okay, good. Now for the fun stuff. Oh, I'm so excited! Now we take away the graphs. Oh my God, so exciting. So exciting. We're going over to the last page here. Oh my God, look at how much room I gave you. I am a giving man. I am a giving man. I hope I gave you enough. Here's what I know. I know that if a function is not continuous, it makes no sense to talk about differentiability. Would everybody agree?
Agree.
So part A is meant to be a review. I'm not going to help anybody for the next 2 to 3 minutes. Part A, let me first of all label my graph. My function, this is f of x. Sorry. So here's f of x, my piecewise function. Okay? Part A, determine the value of k that will make f of x a continuous function at x equals 1. This should be very familiar, very friendly. I know continuity was unit 1, but we still need all those skills. So take 30 seconds, have a strategy conversation with somebody near you. Make sure you're going to do this in the right way. How are you going to find the right value of k so that this function is continuous at x equals 1? Talk to somebody near you.
So limit x equals 1 on the top function, and then we set that equal to the bottom function and plug in 1 also for x. And that's gonna give us this is 47, that's gonna give us
All right. Let's go silent running for the next minute and a half or so. Okay, what I heard in most groups, like, you gotta go through the 3 steps. You're gonna have to show the function is defined at x equals 1. You've got to find the limit as x approaches 1 from the left. You've got to find the limit as x approaches 1 from the right. And you've got to use that to find the just right value for k.
So we're trying to find one to find the limit. So you just go to the left.
what do you do? That's the derivative.
That was the right then.
We can't have this.
Okay, I really want you guys to get some independent practice on this. So unless you have no idea what to do, go solo. I want to see that limit notation. I want to see really good stuff happen. Okay, everybody's going to find the right value for k.
So k equals 8.
Alright, I've seen it from about a half dozen folks. K is equal to 8.
Yes.
Okay. But pay attention to the notation. Stop just for a second. Did you actually label f of 1? Right,
Yes.
f of 1 equals blah. Did you find the limit as x approaches 1 from the left, and you use the function that corresponds to values of x less than 1? At the plug-in part, that's where I stop writing the limit. Find the limit as x approaches 1 from the right. I got this. Great. I need k over 2 to be equal to 4. K is equal to 8. So I'd say something like so. If k equals 8, f is continuous at x equals 1. Done. How many guys honestly came up with k equals 8? Okay, we're making some progress. This is good. Now, that's not the end of the problem. Part B, I have to figure out for this value of k. So from now on, we're going to say, okay, k is equal to 8. Determine if f is differentiable. If I ask the question, is f differentiable? What am I really asking? Well, continuity is a part of it, but when I use that fancy word differentiable, I'm really asking you one question. The function is differentiable if what? If the derivative exists. I just want to know, does the derivative exist? That's what's happening in part B. So I'm really asking you the question, does f prime of 1 exist? But to find the derivative, right? We'd say, oh, so I need to find the limit as x approaches 1 of f of x minus f of 1 over x minus 1. This is our tan. Okay? But if I'm going to find the limit as x approaches 1 of f of x minus f of 1 over x minus 1, I'm approaching from both sides? From the left of 1 and the right of 1?
Yes.
David's like, oh God, no, don't make me do this. Not from both sides. David, stay with me. Limit as x approaches 1. If I'm approaching from the left, which function?
The negative 2x.
Right, it's going to be f of x minus f, I'm sorry, it's the top one. Right? But this guy here just means f prime of x. I'm asking you to find the limit as x approaches 1 from the left of f prime of x. I bet over half of you can just look at that function and you know what f prime is. What's f prime? What's f prime? If I'm approaching from the left, what's f prime? Don't overthink it. Don't overthink it. Marvin, what's f prime going to be?
Negative 4x.
How did you get that?
Multiply the exponent, negative 2, and power minus 1 equals 0.
Sounds like a little power rule action happening over here. And the derivative of 6 is 0. So all I'm asking you is, hey, what's the limit as x approaches 1 from the left of negative 4x? That's easy. Limit as x approaches 1 from the left of negative 4x is? Negative 4. Okay, that's finding the derivative from the left. Finding the derivative from the right, I got some sad news for you folks. Right now, we have no derivative shortcuts for 8 over x squared plus 1. It is not something that you can write as a power of x, which means you cannot use the power rule, even though it's Daisy's birthday and I just want to show you the quotient rule and it makes life so much better, but that's unit 3. The way that we're going to evaluate this limit, we're going to find the limit as x approaches 1 from the right. If I'm on the right, f of x is 8 over x squared plus 1 minus f of 1. F of 1 is going to be 8 over 1 squared plus 1. I think that's 4 over x minus 1. Good news. If your limit skills are strong from unit 1, you know what to do. Sad news, if you're like, limits were not my friend, they're still showing up. So I want to give you guys a couple, because it's part of how the way this course works. So, for those of you that feel really good about finding this limit, go for it. Where are the folks that are going to go through this one with me? Okay, that's some folks, that's not everybody. I definitely need some more board space over here. The goal is... we need to find that limit as x approaches 1 from the right of 8 over x squared plus 1 minus 4 over x minus 1. For the folks that are with me, what's your first thought? You see this 8. Jasmine, what do you see?
Do the cross multiplication on the top.
Okay, right. So 4 is really like 4 over 1. Maybe that makes it a little bit easier for you guys to see it that way. And then that Mr. S thing that he did, he'd say, okay, this guy times this guy minus that guy times that guy in the numerator. So you get the limit as x approaches 1 from the right, 8 times 1 minus 4 times x squared plus 1. Don't forget those parentheses. They are mission critical. The denominator is x squared plus 1. Right, it's the product of the denominators. The thing that I keep seeing happening with our limits is we're forgetting that there is also x minus 1 in the denominator. Getting here is hard. Now I need just careful algebra. So for the folks that are with me on this one, what are we going to do? I want careful algebra. Really, really careful algebra. Noemi, what do you say?
It turns to the limit of x that approaches 1 from the right.
Yep,
8
yep,
minus 4x squared
yep.
minus 4.
Okay, so it sounds like you took that -4 and you distributed it through. That's good. Over x squared plus 1.
A little bit over.
All that's still over x minus 1, right? Is everybody okay if instead of writing this whole thing over x minus 1, I do the next step at the same time? Which is, I'm going to multiply by 1 over x minus 1. Okay, so now I've got the limit as x approaches 1 from the right. 8 minus 4, I've got 4. Minus 4x squared, I've got x squared plus 1 times 1 over x minus 1. I'm kind of picking up the pace now because I think we're at the point where most of us are pretty good. 4 minus 4x squared over x squared plus 1 times 1 over x minus 1. You get a factor? So if I factor out the 4, that leaves me 1 minus x squared. And that is a difference of squares. 1 minus x times 1 plus x in the bottom, x squared plus 1 times 1 over x minus 1. Cancel if you see it. There's some canceling that can happen here. Who sees it? Uh-oh. Jose, you see it? Where?
X minus 1.
X minus 1.
X minus 1 minus x, and it's a negative on the other.
Okay, x minus 1 and the 1 minus x, those are opposite factors, so they're going to cancel and leave you -1. So now I need the limit as x approaches 1 from the right of -1 times 4 times 1 plus x over x squared plus 1. If you're still with me, I just need to find the limit as x approaches 1 from the right. Try plug in. Right, try evaluating. So now I've got -1 times 4 times 2 over 1 squared plus 1. I think that's -8 over 2, which is -4. That was a mean, ugly question. Okay. So, let's do a quick recap. Found the limit as x approaches 1 from the left of the derivative, we get -4. Found the limit as x approaches 1 from the right of the derivative, we get -4. And I heard the saddest little comment from Mariah. She was like, we did all that work to get the same thing. But that's a good thing that they're the same. Why? Why is that a good thing? Daisy, why is that a good thing?
From the right and from the left.
That means the limit as x approaches 1 of the derivative and the limit as x approaches 1 from the right of the derivative are the same. So the conclusion? The derivative exists. A fancier way to say that? The function is differentiable at that point. I realized that was like 2 whole boards worth of work for that little conclusion, but let's write that up and make sure it's really clear. So for the end of part B, I'd want to see something like this. Since the limit as x approaches 1 from the left of f prime of x equals the limit as x approaches 1 from the right of f prime of x, what this means is that f prime of 1 exists. Said another way, this means f is differentiable at x equals 1. That's the conclusion. That's the end of the story. Okay.
That's how I have to write it every time.
And that's what you're going to do to write this up. These are long write-ups. There's a whole lot of skills that come in together. Okay, we've only got a little bit less than 2 minutes left. I want to make sure you guys are clear on what the homework is. On the way in, you picked up a journal entry. Folks that met with me during lunch, you know who you are.